Hi guys, today we're going to talk about a new topic for the limit, and it's going to be the one-sided limits, okay? So now we're going to remove ourselves from using epsilon delta. Now we're going to go ahead and use operators of limits without the definition in the way that it's going to be easier to solve, right? But the key point of this video is to know when does that limit does not exist. So we're trying to look for ways to find the limit, but we have to be cautious about when the limit does not exist, okay? So to be able to do that, we're going to talk about one-sided limits. So the first one is when it says the left-hand limit of f of x as x approaches to c is L. And notice the only difference is this little symbol. Oops. This symbol right here. This minus symbol. This minus symbol in the... So it looks like an operator, right? Because it's an exponent. But because it's a minus sign, you're not doing anything. There's no -1 or -2. It's just minus. So think about it as a symbol. That's very rare in mathematics. Usually symbols, they go in the subscript, not in the superscript. But in this case, they wanted to use it as a subscript, right? So if there's a minus sign, that's the left-hand limit, okay? So we're gonna talk about this topic in a very geometrical way so you can visualize what that means, but it's basically saying that I'm approaching C from the left, okay? And if you remember the previous videos, the arrow means that I'm approaching to that value in X. So C is in my domain. So I'm approaching C from the left, okay? In the same case, for the right-hand limit, instead of a minus sign, you're gonna have a plus sign, okay? Again, C doesn't necessarily have to be negative, and C doesn't have to be positive. It could be either or, right? It could be any real number. That just means that if the exponent of that number is a plus sign, then you're coming from the right, okay? If it's a minus sign, you're coming from the left. Now, a very important key about those things is that for the limits to exist, these four equalities must hold, meaning that the limit from when x approaches c from the left and the limit when x approaches c from the right is they're equal to each other. And once that happens, then the limit is that value that it is equal to, okay? And again, the best way to understand this is using a visual representation or visual example, okay? So now I have a graph here. Okay, and this is very typical. You're gonna see it on the test, this type of example, where they're gonna ask you, find the limit when x approaches -2. Find the limit when x approaches 4. Okay, so we're gonna do those two examples right now. So the limit when x approaches -2 of f of x is equal to one number. Now, to find the limit and to know if it exists, I need to find the limit from the left of -2 and from the right of -2. Okay, so let's do that. So I'm gonna write it over here. Limit when x approaches -2 from the left. Notice that the negative on the left of the 2 is the negative number. And then the minus sign on the exponent is the approaching from the left. Okay? So the limit of f of x is equal to what value? Okay? Now, remember, the limit is a value in the range. So it's a value in the y-axis. Now, at -2, when I approach -2 from the left, so in this direction, my function is approaching this value right there. Now remember in the first video when I said that at the point it doesn't have to be defined? That's okay. But the limit has to satisfy that both left from the right are equal. So from approaching from the left, it seems like the function is approaching the value of 5. Okay? So that is the limit when x approaches -2 from the left. It's 5. Now we're going to do the same thing from the right. So again, -2 with the plus sign, f of x. Now if we approach 2 from the right, so that means like, I'm going to make another arrow from here, then my function is, the value of the function is also approaching 5. So that's the limit when x approaches -2 from the right. Now notice that these two values are equal. That means that the limit when x approaches -2 is 5. Okay? And that's the limit. But notice the main difference. What would be f of -2? So f of -2. So the value of my function at -2. Well, at -2 is this point right here. Okay? And this point is the value 3. So f of -2 is 3. Notice that those two values are not equal. Okay? Again, when in the first video, I mentioned that that was the most important thing about limits, is to be able to have a specific value for which the functions are approaching to, but at that specific point does not necessarily be equal to the limit. Okay, so that's the main thing about limits. That's why we use them, and you're gonna understand better when we start using to define other things. Okay, now let's look at f4. So f4, let me move my my cursor to the right a little bit, and let's just change the color a little bit. Gold. Okay, so now let's do the same procedure that we just did, but for 4, when x approaches 4. So the limit when x approaches 4 from the left of my function. Now, let's approach 4 from the left. So when x approaches 4 from the left, I'm coming from the left here. Notice that at my function, it's approaching this value. That's an arrow. Okay? So that value is 7. Now let's do it from the right. So the limit when x approaches 4 from the right of f of x is equal to what? Well, notice from the right, my function is approaching this value, which is 2. So what can we say about the limit? From the left is equal to 7, and from the right is equal to 2. That means that the limit does not exist. Okay? So the limit when x approaches 4 does not exist. Okay? There is no limit. Now, in your test, you might see it as D and E. Okay? That's what it means. Does not exist. Now, at 4, what is the value of the function at 4? So f of 4. So at 4, we have this shaded one, which is 4. So at 4, there is a value. There is a number applicable to that x value, which is 4. But the limit does not exist. So again, that's the separation of those two concepts. At the point, you can have a value and the limit does not exist. But you can also have a limit and at the point does not have a value. Okay? Now I'm going to show you what would happen if instead of a graphical representation, you have a function and you need to find if the limit exists or not. Okay, so let's try that. Let me just write it next to that graph. Okay, so imagine that I have a piecewise function, and 90% of the time, well, not 90, like 60% of the time that the limit does not exist, it's because of a piecewise function. Okay, so but don't take it too far, because it could exist on a piecewise function. So that's why it says 60. So f of x equals absolute value of x over x. We want to find the limit of that function when x approaches 0. Okay. Now, to be able to separate this function into a piecewise function, we have to use the definition of absolute value as a piecewise function. So this is equal to what? Equals to x over x when x is greater or equal than 0, and then minus x over x when x is less than 0. Okay? So notice that x over x is what? It's just 1. And minus x over x is negative 1. So this is 1 when x is greater or equal than 0, negative 1 when x is less than 0. Okay? Now, usually, well, that probability is higher, like 99% of the time. The limit that you're looking for is the value in the inequality. Okay? Why? Because that's where the limit might not exist. Okay? Any other value, it's going to exist because there's no separation of the function. But at that inequality, that number that appears in the inequality of the statement of the piecewise function, these inequalities, that's going to be the limit you're going to approach to. So in this case, it's 0. So this, again, this is my function. Now, let's do it again. Let's approach the limit when x approaches 0 from the left of f of x. Now, when x is approaching 0 from the left, it means that values of x that are approaching 0 from the left are what? Are negative, right? Because everything to the left of 0 is negative. So which of the two inequalities will represent that? Well, x less than 0, right? This one. Remember, it's not at 0. That's why we use the arrow, because it's not equality. It's approaching 0. So x less than 0 is going to represent x approaching 0 from the left. So it's going to be negative 1. Now, if we do the same thing, the limit when x approaches 0 from the right of f of x, again, which of the two does that represent? Well, we have to choose x greater or equal than 0. That means that I'm approaching 0 from the right, okay? Now, don't get confused with the equality on 0. That's going to be for f of 0. That's when f of 0 matters. But specifically, it's the greater than, okay? So, the limit when f of x approaches 0 from the right is 1, okay? And because these two are not equal, the limit does not exist, okay? So the limit when x approaches 0 of f of x does not exist, okay? But what is f of 0? F of 0 is equal to, there's the equality in this inequality, it's equal to 1, okay? Now, if I move my cursor to the left, this is how the graph looks like, right? So greater than 0. Oh, wait. F of 0 is not defined. Woo! Man, that really caught me by surprise. Tricky. Sorry guys, that was a fast curve right there. Okay, at 0 is not defined. Why? Because we cannot divide by 0. Notice that the function is absolute value of x over x. By definition of a function, x cannot be in the denominator, so we restrict 0 from the domain. Okay, so my bad, my apologies. Hey, I'm human too. F of 0 is not defined, so not defined. Okay, so let's go back to our graph. This is how the graph will look like. And notice the separation, okay? Whenever there is a separation or jump discontinuity, that's a hard word for me, the limit won't exist, okay? So whenever there's a breakage, then the limit does not exist, okay? But that's graphically. Visually, it's easier to spot when the limit does not exist. Function-wise is a different story. You have to go through finding the limit from the left and the limit from the right, okay? So this concludes my video for today. The next example I'm gonna make a little more complicated, but again, it's the same concepts over and over again. So if you like the video, please like the video, subscribe to motivao, share with your friends, and go ahead and write on your computer www.motivao.com to get neat stuff. Okay, have a good one.